Assalamualaikum and hi. I'm Nur Athirah binti Mohamed Dinata. Me and my group will be presenting on Introduction and Principle of Prestressed and Precast Concrete Structure. We will discuss on concept and principle of prestressed concrete, prestressed construction work, precast concrete versus conventional in situ construction method, and the contribution of precast concrete construction. The concept of the prestressed concrete, the placement of initial load on the building prior to its use, distinguish it from conventional reinforced concrete structure. The initial load or pre-stress is added to allow the structure to withstand stresses that can arise during its service time. Pre-stress is applied by extending steel wire and anchoring it to concrete to resist most of the friction and prevent cracking. From the picture, I can explain that in pre-stressing, the tendons are stretched along the axis and concrete is poured. After that, when the tendons are released, the compression is generated at the bottom, which tries to counterbalance the compression due to loading at the top part of the beam. The upward forces along the length of the beam counteract the service loads applied to the member. Now we move on to the principle of pre-stressed concrete. Steel's high tensile strength is combined with concrete's great compressive strength to form a structural material that is solid in both compression and tension in conventional reinforced concrete. The pre-stressed concrete theory states that compressive stresses caused by high-strength steel tendons in a concrete member before loads are added will offset the stresses exerted in the member. Pre-stressing eliminates a variety of structural constraints on span and load that conventional concrete imposed, allowing the construction of roofs, floors, bridges, and walls with longer unsupported spans. This enables architects and engineers to design and construct smaller, shallower concrete buildings while maintaining strength.
For your information, pre-stress can be done in two ways. One is pre-tensioning and the second one is post-tensioning. First, let me talk about pre-tensioning. For pre-tensioning, steel is trenched before the concrete is placed. It was trenched about 70 to 80% and the concrete was poured around the tendon. After that, once the concrete was hardened, the tendon was being released. When highly strength of steel are then to contract, the concrete get compressed. After that, the concrete will be permanent state of maintaining pre-stressed strength. For post-tensioning, steel is trenched after the concrete is hardened. Usually, it was carried out at the site project. Procedure for post-tensioning, concrete is casted and allowed to be dried. Then, the tendon was trenched by the jack and locked with anchor. After that, excess ends of the tendons are then cut away.
Procedure. First step, install sulfate formwork. Second step, install side formwork. Third, install reinforcement. Fourth, install bar shaft for tendon profile. Step 5, installation for post-tension duct. 6. Push strain into duct and install anchor plate with spiral reinforcement. 7. Complete install of every tendon. 8. Complete side of formwork. 9. Complete end of formwork. 10. Concreting. 11. Install anchor head and wedge. 12. Stressing. 13. Cutting end of strain. 14. Install anchor grout cap. 15. Grouting. 16. Remove grout cap. Next, to construction.
What is precast concrete? Precast concrete is a form of concrete that produced off-site. It is prepared and cast using reusable molds and cured at controlled environment factory. While for in-situ concrete is a form of concrete that produced on-site. It is poured, molded, and cured at construction site. The concrete came from ready-mix plant. Why precast concrete is preferred compared to conventional in-situ construction method? For quality control, precast concrete have to go through strict testing to maintain the quality control and getting high strength. While for in-situ concrete, the concrete is tested on site and the variable factors such as temperature and humidity will affect the final strength. If unforeseen weather happens, the progress of the precast concrete will not be affected, but the progress of in-situ concrete will be delayed. The cost of in-situ concrete is higher than precast concrete because it needs more labor and takes longer time to be casted and tested.
How precast concrete can contribute towards reducing carbon dioxide and global warming issues. What is the cost? First of all, we are limited with resources and the populations are growing and consumptions are increasing. We cannot continue to live this way because the future generation will be affected. The increase of greenhouse gas, global temperature rising, increase of sea level and resources depletion has occurred for the past 30 years and continue to rising according to medals. Based on Schattervedi and Oschendorf in 2004, the production of Portland cement has doubled for the past 30 years and it is expected to have this rate in the next century. 1 ton of cement can produce approximately 1 ton of carbon dioxide, which is 7% of the global CO2 emission that is produced by the cement industry. Based on this graph, we can see that the production of cement has increased drastically in the last decade and it is expected to continue this rate for the next century. You can see that it is approximately almost approaching 1,700 million metric tons of CO2 emission in the year 2000. In situ versus precast carbon emission. Based on previous research that has been done before, we could see that the amount of carbon dioxide emission that is released by in situ concrete and also precast concrete. You can see for the left side is the in situ concrete having a lot more carbon emission compared to precast concrete. This is because in situ concrete usually by the name suggested, meaning that the concrete is mixed at the construction area, which cause many excess of cement will be used as wastage, while precast concrete is mixed, is molded at a factory, meaning that the waste is minimized. The use of excessive cement will actually cause more cement to be used, thus releasing more carbon dioxide to the atmosphere.
Advantages of using precast. Firstly, according to the pen in 1986, it was unaffected by weather element due to controlled environment of casting area. Compared to the in-situ concrete, it was affected when the heavy rainfall occurred at the construction site. Next is minimizing cost of transferring waste material due to quality control and reducing waste material. As we know that in-situ concrete always have the waste material and it needs to be removed from the construction site to the another place, and it will cost the transfer involving the project. Next is according to the WISAM in 2005, faster completion of project due to advance of site preparation and simplified installation process. As we know that the in-situ concrete must be casting at the site and it needs time to prepare compared to the precast that have been set up at the factory. Next is to promote safe, systematic factory working environment as minimal workers, materials, and construction waste is required on site. This was according to IDB 2003B. Lastly, it can reduce of waste materials at site due to casting in the factory. Okay, for the conclusion, in conclusion, global warming was produced from the carbon dioxide and other pollutants collected in atmosphere and absorb the sunlight that have bounced off the Earth's surface. As we know that construction industry was one of the main producer to the global warming because it produced the high of air pollutant and carbon dioxide emission. So the precast concrete can contribute to the reducing of carbon dioxide in the construction site due to many factors compared to the in-situ, because the material used was reducing and it was not casting at the site, and it can be controlled due to the safer place. That's all. Thank you.